We know that when x is positive, modulus x is equal to x. When x is equal to 0, modulus of x is equal to 0. And when x is negative, modulus of x is equal to minus of x. Plugging these values into the expression for fx, we get when x is positive, fx is equal to, in brackets, x plus x whole times x, which is equal to 2x squared. When x is equal to 0, f of x is equal to 0 as well. And finally, when x is negative, fx is equal to, in brackets, x minus x whole multiplied by minus x, which is 0. Now fx is continuous for all x except potentially for x is equal to 0. To establish continuity of fx at x is equal to 0, we look at the limit of fx as x tends to 0 from the positive side, which is equal to the limit of 2x squared as x tends to 0 from the positive side, which is equal to 0. Similarly, the limit of fx when x tends to 0 from the negative side is 0 because the value of fx when x is negative is equal to 0. And finally, f of 0 is equal to 0 as determined above. Putting these three results together, we note that the limit of fx when x tends to 0 from the positive side is equal to the value of the function at 0, which in turn is equal to the limit of fx as x tends to 0 from the negative side. And therefore, fx is continuous at x is equal to 0. And we've already noted that fx is continuous at all points other than x is equal to 0 as well. Therefore, fx is a continuous function for all values of x. Now, f dash x is equal to 4x, which is the differential of 2x squared when x is positive, and is equal to 0 when x is less than or equal to 0. Now clearly f dash x is continuous for all values of x except potentially x is equal to 0. To establish continuity of f dash x at x is equal to 0, we look at the limit of f dash x when x tends to 0 from the positive side. This is equal to the limit of 4x when x tends to 0 from the positive side, which is equal to 0. Similarly, consider the limit of f dash x when x tends to 0 from the negative side. This is equal to 0 because f dash x is 0 when x is negative. And finally, the value of f dash 0 is also equal to 0 as determined above. Putting these results together, we note that limit of f dash x when x tends to 0 from the positive side is equal to f dash 0, which in turn is equal to the limit of f dash x when x tends to 0 from the negative side. Therefore, f dash x is continuous at x is equal to 0, and we've already noted earlier that f dash x is continuous at all other points as well. Therefore, to conclude, both fx and f dash x are continuous for all values of x, including x is equal to 0.